Now this equation here written in these terms gives us a function defined in terms of an expression. That is what we mean is this, that f, a function which I'm going to elaborate in a moment, okay, it takes on values based on this expression. For example, say you give x the value 0, or you give function the input of 0, okay, then it will give you an output of -9. Likewise, say you give it, say you give f an input of -1, okay, then here we go. So -1 square is a 1, minus 9 is -8. And likewise, say we decide to give it the value, say +1, the input value +1. So what we are doing is we are giving x a value, and the value given to x is called an input, and then we are computing and then we are using this rule to transform that input value. And in here you can see that it gives 1, the value -8 again. And say we give f a value, say square root of 2, just taking a number, okay, then what do we get here is we simply get, see, I'm just going to change the input here, okay, and so put that as square root of 2. Square root of 2 square is 2, minus 9 will be -7. So this is how this this tool works for you, that if you give x a value, then fx returns another value for you for that given value. So for example, here for a 0, it returned us a value of 9, okay. Then here for -1, it returns us a value of -8, or for input -1, it gives us an output of -8. And here, even in the case of 1, it gives us output of -8. And then for a square root of 2, it gives us an output of -7, or in other words, it assigns -7 as the value to square root of 2, negative value as the value for or the value to 1, okay. So that's how a function is behaving, and as I said, we are going to define function more precisely a little later, okay. Now here in this case, this this expression x square minus 9, that is valid for all the values of x, okay. That is, any value of x can be substituted in here, and we will have x square minus 9 available for it. So here it's valid for all real numbers x, okay, or it gives us a real output for all real numbers x. So what we do here is we call the domain of f the set of all real numbers, okay. So domain of f is the set of all real numbers, okay. So now, and you can see it a little further. Now, since a graphing calculator is our companion, we may go ahead and look at a graph of this function, okay. So here, and you can see it's a quadratic, and it's a parabola opening up, and we have an output for all the real number inputs here. Or look at it another way, here is another picture of the graph, and we had obtained these values in the beginning, and we can note that we are assigning 0 the value -9. Let me change the color here, okay. So, and the thickness, so there we go. So we are assigned 0 the value -9, and then -1 is -8, and without even calculations we may notice that, say, if we look at 4 is going to what, approximately 7 here, which we, if we recall the expression, it's 4 square minus 9 equals 7. Okay, so then now I brought the expression of the function here for you, and what you can notice is this, that this expression is valid for any real number x. Okay, all right. So what you say in this case is this, that the domain of the function that we have is the entire set of real numbers. Okay, and let's take another example, a slightly different one. Now let us take up a function defined by this expression here. Okay, so which is x plus 3 over x minus 4. Now we have a denominator here which is different, which is a variable denominator, so we will have to be a little careful. So what I'm going to do is that I'm going to write in this table the values of x for various inputs. So if I take my input as 0, you can see that the output is what here? That's 0 minus 3 over, sorry, 0 plus 3 over 0 minus 4, that is negative 3 over 4. Okay, and then for 1 it would be 1 plus 3 over 1 minus 4, that is going to be negative 4 over 3. Okay, and in this manner, if we just proceed, let's write it for 2 also. Okay, just taking a few more minutes of this video time. So that's going to be negative 5 over 2. For 3 it is 3 plus 3 is 6. 3 minus 4 is negative 1. So we have negative 6. But when we come to 4, then what happens here is that I can substitute a 4 here, but I'm not allowed to substitute a 4 here because that will give us a 0 in the denominator. Now, fortunately, you may notice here that that's the only trouble spot in this case. That is, if x is 4, the denominator is 0, and which is not defined. So what happens in this case is, for this function, you will say that the domain of this function is the set of all real numbers except 4, which is also verified by a graph of this function, that you can see that at 4 the function has a big break here. Okay, so for the domain, what we can say is domain is the set of all real numbers. Okay, all real numbers except 4. Okay, and we will see how to write this as more formally in a minute. So I mean, we are taking another example here. Say fx is square root of x. So here you can see it is valid only for who? For the values of x that are 0 or higher, because otherwise it doesn't give us a real output, right? So it is valid for x greater than or equal to 0, and the domain of this function therefore will be given by all real numbers that are greater than or equal to 0. Or another way of writing this is what? You are writing the values starting from 0, and 0 can be assumed as a value, so we put a bracket at this place, and then on the right it can go on to take any real value. So I'm putting an open bracket here or parentheses here, and we are symbolically writing infinity, and with the infinity we cannot write a bracket here anyways. Okay, So this is the domain, and if you graph this function, you can see that we don't have any output in this direction, and the domain of the function is the set of all real numbers, 0 onwards to the right. Now let's take a function. Now note that a computer generated graph may not always show you the points that cannot be in domain. For example, here you can see that at x equals 1, this expression is not defined. Still, this graph shows us an output at 1. So, but you know that this can't be true, right? So that is, here we should have what? We should have a discontinuity that we can express by putting a hole over here. So in other words, what we have is this, that x equals 1 cannot be in the domain of this function. Okay, so the domain of this function is real number values of x such that x is not equal to 1, or in another notation, union of these two intervals expressing that negative infinity to 1 can be domain, can be part of domain. So does 1 to infinity, but 1 cannot be in the domain of this function.